Ladies and gentlemen, Dr. Michio Kaku. Dr. Kaku, welcome back to the program.
Art, glad to be on again.
It's always so good to hear your voice. It really is. I am going to be in your fair city next week.
Oh, is that right? New York City?
Yes, sir. New York City.
Big Apple.
The Big Apple. Recluse Me is going to break away and go all the way to New York City for the premiere of The Day After Tomorrow, that movie.
And congratulations. It's not every time that somebody has a big Hollywood blockbuster.
Not every day.
Based on a book they wrote.
Yeah, not every day, huh?
Mm-hmm.
Well, based in part on the book we wrote anyway. And, of course, Roland Emmerich has added his magic touch to it. And it sure has... Holy mackerel. I have a pile of stories here. Some scientists in Britain are saying, ha-ha, yes, here it comes. Others are saying, rubbish. And it's a big, giant controversy, and I keep trying to say it's a science fiction movie, but administrations are worried. NASA, oh gosh, NASA, first they came out I was on the air, and NASA said, our scientists will not comment on this movie. They will not say a word. And then by the time I'd finished first hour, all of a sudden there was a reversal from NASA, and they said their scientists, well, okay, they can comment on it. So what a mess. It's a movie.
Yeah, I think scientists are like ducking for cover, especially NASA scientists and government scientists.
You think so?
But I think your movie is going to be a real seat of your pants movie that's going to open a lot of people's eyes.
Yes. Well, if one looks at the archaeological evidence, and there is some which many scientists choose to ignore, there have been rather fast climate shifts apparently in our past.
That's right, 8,000 years ago and 12,000 years ago. And, many ice ages have taken place because when you tinker with Mother Nature and you tinker with the Gulf Stream, you tinker with the collapse of the atmosphere itself.
Yes. Are you aware of the measurements taken by Woods Hole and others? Very reputable scientific organizations that say the Gulf Stream is beginning to slow.
Yeah, there's, as the North Pole melts, fresh water begins to pour into the North Atlantic, and that's what we're worried about. The salinity of the North Atlantic is changing now, and that could be the tipping point, the butterfly effect. That could tip it over. And like we physicists say, even a butterfly at a certain tipping point can create a thunderstorm. The injection of large quantities of fresh water from the melting North Pole could be a tipping point for the North Atlantic Gulf Stream, in which case, hold on to your pants. Oh,
I know. Europe indeed could freeze. Western Europe could freeze. It would be a disaster, and I think that's why there's such a mess, Doctor, over this movie, because to me, the best science fiction has always been that based in possible or even probable reality.
That's right.
And then you scare the hell out of people about that. I mean, that's good science fiction to me, my kind of science fiction. I don't like the fantasy science fiction. I like something that's based on, like Contact, for example. I thought it was superb. There's a lot of movies I really love, but most of them are based on at least possible reality, and maybe we got a little close with this.
That's right. There's a difference between Lord of the Rings and Jurassic Park.
Indeed.
Lord of the Rings is just pure fantasy. No one thinks there's a kernel of truth in Lord of the Rings.
Right.
But the Jurassic Park, there's a kernel of truth there, So it's something that you really have to think twice about when you see the movie Jurassic Park. And I think in situations like this, it's another situation where you really have to think twice. Is there a tipping point for the North Atlantic Gulf Stream? And we have one big science experiment, the planet Earth, basically, we're tinkering with.
All right. Let's move away from that. Enough plug into the movie, even though it is fascinating and the debate's fascinating going on over it. I've got somebody asked me a few weeks ago a question that I haven't been able to yet answer. What is the speed of gravity?
The speed of gravity, we think, is the speed of light.
We think or we know?
Well, that's one of the reasons why NASA sent a $700 million gravity probe B into outer space just last month. It's one of the most expensive space probes that NASA has ever sent, a robotic space probe into outer space. And it will try to test once and for all Einstein's theory of general relativity, the foundation of modern cosmology, the foundation of black hole research. We want to nail it to the wall. And this is big business now, trying to confirm Einstein's theory.
Okay, well, little old talk show me thought about it when the caller asked, and I thought, well, maybe you can't measure it because gravity is related to mass, correct?
That's correct.
Okay, and if the mass is already in existence, short of being able to create sudden mass, I'm not sure how you would measure it. How do they plan to do it?
Well, if you were to wiggle the mass, vibrate the mass, you would create waves of gravity emanating in all directions. And these waves, like a fabric, travel at a very definite velocity, and that velocity, we think, is the speed of light, because space is not empty. We think space is like a fabric that can flap and bend and stretch. And we think that waves can move along this fabric. Like if the sun were to disappear, right now, it would take you 8 minutes to realize that, my God, the sun just disappeared.
Right.
And then 8 minutes later, the gravitational pull of the sun would disappear, and we'd be flung into outer space. Now, of course, we've never done that experiment, but we do believe that if the sun were to disappear, it would take 8 minutes for the Earth to fly into outer space.
Disappointing. We wouldn't have any warning at all. Well, maybe we would. We've got that satellite out 1 million miles, right?
Well, we have the Gravity Probe B out there, and it's supposed to measure what is called the missing inch.
No, I meant there's at about 1 million miles, I believe we've got a satellite that observes the sun.
Oh, yeah, that's right. There are satellites that observe the sun.
Oh, but wait. No, the signal coming from that satellite would be coming at roughly the same speed, so we wouldn't get any notice at all.
That's right.
Darn.
Light and gravity both would take 8 minutes to arrive at the satellite. And so we would have basically no notice at all.
Not even enough time to go, oh, damn.
Nope.
Or something.
not even enough time for that.
All right, we're going to talk a fair amount tonight, I guess, about Einstein. Your book is about Einstein.
That's right, Einstein's Cosmos.
And what inspired you? Why did you want to write about Einstein?
Well, next year is the 100th anniversary of relativity and E equals mc squared. And there's going to be a lot of hoopla next year. Next year it's called the World Year of Physics, as we celebrate 100 years of relativity. And this means conferences, this means TV specials. I just taped a TV special with National Geographic Television.
Oh, really?
Quite a few different channels are going to be doing Einstein specials. And I just finished writing an 8-page spread for Discover magazine for their September issue. So there are going to be a lot of specials heating up later this year and into next year.
You do very well on television.
Oh, well, thank you very much.
You really do. How do you manage to handle it? TV is so very different than, for example, what we're doing right now. It's a totally different world.
Well, I just try to think like I'm talking to students or talking to a young person. And then you don't want to impress them with big-sounding words. Einstein once said that unless the theory can be explained to a child, the theory is probably worthless. Physical pictures, is what motivated Einstein. And we now realize that these children's pictures are what, motivates the universe, pictures that children can understand. And so when I'm on TV, I simply say to myself that I'm talking to a young person.
Well, I must say it works very well. And I remember seeing you on what was it? I mentioned it to you. It was a kind of an odd channel that I caught you on doing an interview. And I thought, what's he doing on that channel? But boy, was it ever a good interview. And I thought, there is the next Carl Sagan. And I guess you are the next Carl Sagan.
Well, thank you. I try to reach people.
You do. Mm-hmm. You do. That's a very unique talent, particularly in a very short amount of time, to be able to impart, understandably, such complex issues. The nation has to have people like yourself.
Mm-hmm.
So I hope that's a job that you sort of would welcome. It seems like you are.
Yeah. That's not my main thrust. My main thrust, of course, is trying to complete Einstein's dream.
Yeah.
But it's always good to, tell the public, why are we spending so much effort and billions of dollars to try to complete Einstein's dream?
How old are you now, Doctor?
Oh, I'm getting on. I'm 57 now.
57.
Yeah. Mm-hmm.
At 57, there are some who would suggest that you're past your brilliant time. And there's a sort of a thing in science, is there not, that suggests only the young, the brilliant will come up with Einstein-like insights?
Well, there is a tradition in math and physics that says that the greatest geniuses, the supernova ideas that change everything,
yes,
take place when you're very, very young.
Is that truth, or?
However, other physicists and mathematicians have been productive into their 70s.
Einstein?
Einstein was productive into his 70s, even though a lot of biographers, I think, totally misread his latest work.
A lot of controversy about that, right?
That's right. A lot of people thought that he was over the hill after age 40 or so. And, now we have space satellites, laser beams, gravity wave detectors, high-speed computers that can test many of the predictions that Einstein made later in life that people laughed at because, there was no way to test some of his later predictions. And so that's why, that's one of the reasons why I wrote Einstein's Cosmos, to correct this mistaken opinion of biographers that he was over the hill.
And how were you able to assess in your mind for writing the book that, in fact, he was not over the hill, that some of his greatest insights came later?
Because he was pushing the boundaries of relativity theory. He was getting into wormholes. He was getting into higher dimensions. He was getting into all sorts of research that took him in directions that were totally untestable in his time. Realize the Nobel Prize Committee couldn't give Einstein the Nobel Prize for relativity. They gave the Nobel Prize to him for the photoelectric effect, which is the basis of modern television, for example. Television owes its existence to Einstein's theory, because they couldn't get their mind around relativity. It was very difficult to test in his time. And it really wasn't until the atomic bomb was created that a lot of naysayers finally said, oh, my God, Einstein was right. E equals mc squared.
Yes. How do you feel about the fact that he made the atomic bomb possible? And for a second, if Mr. Einstein had never lived, how much farther along in history do you think the atomic bomb would have dawned on the world?
Well, many people in 1905, almost 100 years ago, were close to relativity, but they just couldn't make the final leap. I think in another 5-10 years, people would have finally completed the last missing piece of the jigsaw puzzle and said E equals mc squared. But general relativity, which gives us black holes, curved space, the possibility maybe of time travel, that was maybe 50 years ahead of his time. And so for one man to get two of the greatest theories of all time is astonishing.
It is. It is. But 5 years is not a long time. And do you think that's generally true of science, that a discovery is going to be made in a very narrow window by possibly quite a number of people, no matter what? I mean, we just stumble forth?
Yeah, well, great breakthroughs are made when there's a contradiction between the reigning paradigms, and quite a few people were saying that there was a contradiction between Newton's common sense laws of motion and the theory of light, Maxwell's theory of light. But no one could put the whole picture together. Poincaré, Lorentz, Fitzgerald, a lot of them had pieces of it, but no one saw the big picture, that space itself could shrink, that time could slow down. I mean, who would have thought that time itself is not an absolute? That's embedded into our conscious mind.
It is.
You know, if it's 12 o'clock on Earth, it's 12 o'clock on Mars. 1 second on Earth is 1 second on Pluto. But that's wrong. So it took somebody like Einstein to make that leap and to say that a second and a meter stick are not the same throughout the universe. Einstein used to joke that he put a clock everywhere in the universe, each beating a different rate. But in his own life, he was so poor, he could not afford to buy a clock for his own office. That always is going to lead me to my favorite topic, which is time travel. And I guess it's a matter of power, but you don't see time travel, particularly to the future, as an impossibility at all, do you? Well, Einstein was grappling with time travel in his later years. His office mate down the hall was Kurt Gödel, perhaps the greatest mathematical logician of the last 1,000 years. He disproved the dream of the Greeks concerning the foundations of mathematics. But Gödel then, created the first time travel solution, that if the universe rotated, time travel would be commonplace. And so Einstein was really shook up. And in his memoirs, he mentions this. He mentions the fact that time travel was always in the back of his mind when he formulated general relativity, and he wanted to find some way to eliminate it. But here was his office mate already finding solutions that allowed for time travel. Very disturbing.
Why would he take the tack of trying to eliminate it?
It was too much even for Einstein. Here was Einstein, who gave us matter, energy, the secret of the stars, black holes, space warps. Time travel even boggled his mind. But here was his office mate down the hall, who was finding a solution of Einstein's theory for rotating universes that allow for time travel. And since then, by the way, hundreds of solutions have now been found of Einstein's equations which allow for time travel. None of them, of course, are practical, but we physicists are goggle-eyed, realizing that it is a possibility allowed within Einstein's theory. It's something that we cannot dismiss, in other words. We can't laugh at it.
No. I suppose if time travel is possible to the future, then the old question of where are the time travelers is therefore answered, because you can't travel in the past, and we'll be around if it's announced, oh, we've managed to get time travel into the future. We'll be there for that.
Time travel into the future is allowed by Einstein's theory of 1905. So that's well established with our space probes. Our astronauts, by the way, every time we send an astronaut into outer space, we actually send them into the future a little bit. Not by much, of course, a fraction of a second. But every time an astronaut goes up in outer space, time slows down for him. So in other words, he is, shot into the future. So in the future, when we get space probes that can reach stars and reach near the speed of light, we'll actually be sending them into the future. So future travel is a reality. We've tested it. The GPS system that a lot of people use to locate their position on the planet Earth.
Sure.
The GPS system would fail without relativity. Pentagon generals have to be briefed on Einstein's theory of general and special relativity because it is so essential for very accurate timekeeping on the planet Earth.
All right. Hold it right there, Professor. We've got a break here at the bottom of the hour. We'll be right back. Professor Michio Kaku is my guest.
Talk with Art Bell. Call the Wildcard line at area code 775-727-1295. The first-time caller line is area code 775-727-1222. To talk with Art Bell from east of the Rockies, call toll-free at 800-825-5033. From west of the Rockies, call Art at 800-618-8255. International callers may reach Art Bell by calling your in-country Sprint access number, pressing option 5, and dialing toll-free 800-893-0903. From coast to coast and worldwide on the Internet, this is Coast to Coast AM with Art Bell.
Hope you're having a wonderful weekend, everybody. Spooky from Enterprise, Alabama, right? Say, Art. If every time we send someone into space, they travel a little bit into the future, well, then how come we can still see them when they come back? And I thought, silly question. Then I thought, no, it's not. That's actually pretty good. We'll ask. A quick note about fast blasting. And that's the ability to go to the website at coasttocoastam.com, hit Fast Blast, and then type in a message to me, which will then appear on my computer screen at the speed of light. Well, maybe not, but pretty quickly. And the best thing for you to do, and the best way for you to get one of your Fast Blasts on the air, is to ask a relevant question of some sort of Dr. Kaku. And when I'm looking at Fast Blast during the course of a show like this, I'm kind of looking for that sort of thing. So if that helps you decide what to type out and blast away at me, then so be it. Dr. Kaku, is kind of a dumb question, but it's not. I mean, if that astronaut has proceeded a second or two into the future, then how are we able to view him when he returns?
Well, we have the science fiction impression that when you go into the future, you disappear and then you reappear someplace else.
Right.
But it's actually more mundane than that. If I take an alarm clock and I throw it into outer space, the alarm clock simply slows down. That's the way we've always measured it with our instruments, that clocks slow down when they go into outer space. You can see the clock. It's visible by telescope, but it simply beats slower. So when the clock comes to rest, and you look at the clock's frame, you find that it's backwards compared to your clock. So if you were on the clock, you basically went into the future. So the clock looks like it's in the past, which means that from the clock's point of view, everything else is in the future. It's like suspended animation. If you were to send astronauts into outer space under suspended animation, right, and you woke them up, they would wake up in the future. But all you've done really is slow down their time. You slow down their biological processes by putting them to sleep in suspended animation. So that going forwards into the future is the same as having your clock slow down. And this has been measured, with our space satellites. The GPS system depends upon it. In fact, all our satellites would be out of whack unless we compensate for the fact that when we send satellites into outer space, we actually send them into the future slightly.
But if we could devise a method with all the power we needed, the power of a sun or whatever, and we could toss somebody forward into 2012, they couldn't be here and in 2012 simultaneously, could they?
Well, if you look at them, they would look frozen.
Really?
So again, if you throw an alarm clock into outer space and you look at it from the telescope, and the alarm clock is moving very close to the speed of light, it looks frozen.
So in other words, if there really was a time machine and I blasted forth to 2012, you would see me as a frozen figure sitting in the time machine.
For that period of time. That's future travel. Now, past travel is much more difficult, and that requires the general theory of relativity. That actually requires warping the fabric and ripping the fabric of space and time. But to go forward in time is well established.
That's so fascinating. Not one science fiction movie has ever depicted it as they should have then.
That's right. You are from here to now, from here to the future, you're frozen, so you look like you are stationary, frozen in time.
Indeed.
Like suspended animation. So when you wake up, you essentially wake up far into the future.
Question. Would that frozen figure, if observed over a period of time with a time lapse or something, actually in reality not be totally frozen?
That's right. The person would actually be moving very slowly because his clock is slower compared to my clock.
Got you.
So we can see his clock at any time. At any time, we can even touch his clock and see his clock. It's just that his clock runs slow compared to our clocks. So when he finally comes to rest, he's way in the future. So that if we send a starship to the nearest star, 4 light years is what the distance is normally. It would take 4 years for a starship to reach Alpha Centauri. But for the starman, for the star person in the rocket ship, it may take him just like a minute, a second, to go to the nearest star. And if we look at him with a telescope, he looks frozen throughout his journey, moving very slowly. So by the time he gets to the nearest star, we measure 4 years. He says it's only been 4 seconds.
All right. You said time travel to the past, a very difficult, much more difficult.
That's much more difficult, right?
But you didn't say impossible. Or do you want to say impossible?
No, not impossible at all. In fact, in the pages of Physical Review magazine, there are all sorts of proposals and blueprints being proposed by physicists to go backwards in time. These are solutions that are consistent with the laws of physics. However, I should point out that the main problem with these blueprints is the gasoline. The gasoline necessary to take you backwards in time would be comparable to an exploding star, a black hole. But in principle, yes, Einstein's theory of general relativity has hundreds of solutions which allow for various forms of time travel. Not just the Gödel solution, but we have the Tipler solution, we have Neumann-Unti-Tamburini solutions. We have a whole book of solutions that allow for time travel.
Well, that's pretty spiffy, but that really does then bring on the question, then where the hell are they?
Well, my point of view is if you watch a dinosaur have lunch, the first time you do it, it's quite dramatic. But after you see a dinosaur have lunch a million times, you sort of lose interest. Well, I think pretty much that they've lost interest in us. We're not that unique. We're not that interesting to them. I mean, after all, if you see a bunch of ants on the floor, do you want to communicate with the ants and videotape the ants? I don't think so.
Well, there have been times actually where I have laid down on the floor and watched ants for a while. It's rather intriguing.
And then you get bored.
You do. You get bored.
That's right.
But they do march along just in single file. It's quite remarkable.
So I think they probably visit us a few times, and after that they say,
so you really
been there, done that.
You think we've had visitors?
It's conceivable. I mean, if somebody knocks on your door and claims to be your great-great-great-great-great-great-great-granddaughter in the future, don't slam the door. It's conceivable that our own descendants, far in the future, may eventually harness what is called the Planck energy and, exploit a hole in space and time and visit you. Again, this is still controversial, but there are physicists who claim that, yes, we can visit our parents before we're born.
Huh. And the age-old question, of course, of doing harm to one of your parents, your answer, as I recall it, is that we create at that instant an impossibility that causes a new bubble, a new universe in which things unfold in a different way?
Yeah, the timeline, the river of time forks into two rivers. So originally I have one river, and then it forks into two rivers. Now, some scientists believe that you get a whirlpool instead of a fork. If you get a whirlpool, then you go backwards in time and simply fulfill the past. So it was written that a time traveler would enter your time frame in the past. Mm-hmm. I don't think so, because then you have all sorts of paradoxes if you have free will and can monkey with the past, right? More and more physicists believe that the river of time simply forks into two rivers, two quantum rivers, basically, that coexist. And this is the many worlds theory. And quite a few Nobel laureates now are swinging over to the many worlds theory.
Not to be confused with other dimensions?
Yeah, this is ordinary garden variety, three-dimensional Twilight Zone type episodes.
Huh.
Remember that episode of Twilight Zone where a man wakes up and finds out that no one recognizes him because he was never born?
Yes.
Well, that's conceivable because one quantum event could cause a miscarriage in your mother. One cosmic ray could cause your mother to have a miscarriage, in which case you were never born. So one quantum event separates two universes, one universe where you were born and another universe where you were not born because your mother miscarried. One quantum event, one cosmic ray can separate two universes. And, for those of us who believe in the many worlds theory, it means that there are many quantum worlds that we exist with simultaneously.
Okay, I'm a little confused here. In other words, I understand the concept of 11 dimensions, let's say. Are you suggesting that going back and doing something awful would put you into another dimension, or would put you into something else that is not one of the identified or not yet identified 11 dimensions?
Well, these 11 dimensions are dimensions of space. They're dimensions that are beyond human ken. And again, many physicists believe in these things. The dominant physics